Now, last time what we talked about is we were looking at the effects of having passive elements. We looked at resistors, we looked at capacitors, and we looked at inductors. These are the major components in an AC circuit. And we saw how to do calculations. When you're told to find the current, you're told to find the resistance, you're told to find what else? The phase angle. Yeah. Now today we're going to look at a couple of examples. When you're given a question and you're told to find the frequency, the period. I don't know if you can remember what frequency is. Can anyone tell me what frequency is? Anyone? Frequency ni nini? We had mentioned this in the first class. We want to just do two examples that we had done previously on frequency and time period. So what is frequency and what is time period? Let me see. Edwin or Cheng, what is frequency? Frequency ni nini?
According to me, frequency is the number of the circles per second.
Yes. That's the explanation. It's the number of cycles per second. And the time period is the time taken to complete one full cycle. So that's how. Now we had done these two examples during our first class, so I'm repeating these examples for the sake of those who weren't there. Now, when you're told mfano, kuna swali, you're told that determine the periodic time for the frequencies of, unapatia frequency of 50 hertz. That is this unit of measurement of frequency. And I don't know if you can see my screen clearly. Mnaweza ona ni calculations zangu mali naandika vizuri.
The writing is not clear.
Okay. Mnaona sasa?
Yeah, I can see.
Okay. Now, you have been told to find the time period, the periodic time of a frequency of 50 hertz. Now, time period when you're given frequency is equals to 1 over frequency. Right, together. When you're given frequency, you can find the time period by dividing 1 over the frequency. Now, in this case, you're told that you're told to find the time period of a frequency of 50 hertz. So time period will be equal to 1 divided by 50. So what will be our time period? Umepatia a frequency of 50 hertz. What will be our time period?
0.0.
You'll get that our time period is 0.02 seconds. Remember to always indicate your units. Now you've been given a frequency of 20 kilohertz. 20 kilohertz. When you indicate kilo, that means that this value 20 is multiplied by 1,000. Your value imekuwa multiplied by 1,000. Therefore, our frequency will be equal to 20,000 hertz. Remember, when you're doing any calculation, always make sure that the unit is in the base unit yake. Kama ni mass ni kilogram, kama ni time ni seconds, kama ni force ni newtons. So if you're given kilonewtons, meganewtons, always make sure that umerudisha to its base unit, in this case newtons. So kwa frequency itakuwa hertz. Now what will be the time period? time period will be 1 over the frequency, and the frequency is 20,000 hertz. Not 20,000, 20,000. So what will be a time period?
5 times 10 to negative 5.
0.00005 seconds. 5 times 10 raised to power negative 5 seconds. Those are still the same answers. So make sure that when you're doing your calculation, your unit equal in its base unit. If you had taken 1 over 20, that answer will have been wrong. So
It's okay.
now,
So kumaanisha whenever I'm given kilohertz, you multiply by 1000 to make them hertz.
yes, you multiply by 1000. If you are given 20 megahertz, this is 20 times 10 raised to power 6, ama 20 times a million. Always make sure unabadilisha inakuwa into its base unit hertz. Kama umepatia 20 gigahertz, this is 20 times 10 raised to power 12. So always ensure that the value ambayo unapata ama the value ambayo unatumia ni its base unit. Sawa. Okay, now that is the period, the time period when you're given frequency. Time period is 1 over f, 1 over frequency. Now, when you're told to find frequency when you're given time period, it is the opposite. Frequency is equals to 1 over the time period. Sawa, mfano, you have been told to find the frequency and the time period ambao umepatiwa ni 4 milliseconds. 4 milliseconds. Now, milliseconds, when you convert 4 milliseconds to seconds, itakuwa ngapi? When you convert 4 milliseconds to seconds, zitakuwa ngapi? Remember I told you to easy values, mega, kilo, lazima mzishike. When you're told kilo, is you're multiplying by 1000. When you're told mega, you're multiplying by 1 million, 10 raised to power 6. When you're told milli, you're dividing by 1000. When you're told micro, you're dividing by a million, 10 raised to power negative 6. These things you have to know them. These are the 4 basic ones. But this can go even further. I remember the first class we did, physical class tulipatana, I think nilipitia hizi vitu. If not, I'll just draw them into a table and then I'll send them to you so that you can be able to mzijue. So in this case, umepatia 4 milliseconds. When you convert 4 milliseconds to seconds, itakuwa ngapi?
0.004.
You're given 0.004 seconds. Sawa. Now let us find the frequency. Frequency will be 1 over that time period, which is equals to 1 divided by 0.004. So what will be the frequency? We have 1 divided by 0.004. 250. 250 what? 250 cars, cows, people, hertz. Sawa. Always indicate your units. Ukishamaliza calculation, indicate your units. Now, try this one. You're given a time period of 4 microseconds. 4 microseconds. When I say micro, what am I dividing it by?
6.
You're dividing it by a million, 10 raised to power negative 6. So when you convert 4 microseconds to seconds, itakuwa ngapi? 0.12345 seconds. So you have converted this time period into seconds. Now, what will be the frequency? Frequency is equals to 1 over the time period. 1 over the time period. And the time period, tumeona ni 0.000004 seconds. So what will be a frequency?
250.
250? 250. 250,000 hertz. You can simplify this answer by unaweza andika mfano 250 kilohertz. What I've done is I've divided it by 1000. I can also write it in terms of megahertz. Na itakuwa 0.25 megahertz. What I've done is I've divided it by a million. So you should be able to convert your values from its base unit kama hertz to microhertz, millihertz, kilohertz, megahertz. But if you give me any of these answers, ni sawa. They're all correct. 250,000 hertz, 250 kilohertz, 0.25 megahertz. But if you're going to give me the answer in this simplified form ya kilohertz na megahertz, then you have to show me how you got that answer. Unaona kama hapa uweze kuja ukaniambia 1 divided by 0.00004 itakupatia 250 kilohertz. No, it will give you 250,000 hertz. Then uniambie 250,000 divided by 1000 will be equal to 250 kilohertz. And that I'll give you as a tick. That will be a correct answer. So you don't jump straight from here. Usiruke straight from here, divide 1 divided by this, ukapata 250 kilohertz. No. Get this first, 250,000, then show me that you've divided by 1000 to get 250. But I want you to get that formula. Once you're given, you can be able to find time period if you have frequency. And you can also be able to find frequency if you've been given time period. Sawa sawa. Any questions? Do you have any questions up to that point? If you're together, unmute and say I'm present. Nisikuwa naongea peke yangu. The only person naona akiongea ni Edwin. David, Emily, Haitham, Godfrey. Tuko pamoja. Ama mmeingia tu mkazima microphone na camera na mka. Okay. Now, also there is something I had mentioned last time. AC values. When we talk about AC values, there are some terms that we had mentioned. The first one we had mentioned was instantaneous values. And what are instantaneous values? These are the values of that alternating current, that alternating voltage at a particular time or at any instant in time. And I've given an example of this sinusoidally alternating voltage and current. When this voltage, let's say this is voltage that is varying with respect to time. When I ask you to labda in this graph, I tell you to find me the voltage at this time t. That voltage at this particular time t is that instantaneous voltage at that time, and it will not be the same as the voltage at this time. It will not be the same as the voltage at that time. So it will differ. The voltages will be different. So when the instantaneous value of an AC source, it is the value of that quantity, that alternating quantity. We used to kama ni voltage, kama ni current, sawa, at any instant in time. Now, we represent these instantaneous values with small letters. So kama ni current, it will be small I. If it is voltage, it will be small v. Instantaneous values are represented by small letters. Now, kuna another value, AC value, which is known as peak value. Peak value. Now, peak value is the maximum. It is the maximum value reached in a half cycle. Mfano, we have alternating quantity represented graphically. The peak value, this is our half cycle. Here hapa mpaka hapa. This is our half cycle. If I was to draw a full cycle near here. Now, the maximum value of an alternating quantity in half a cycle is what we call peak value. I don't know if you can see my screen clearly. Hamuoni kabisa? Okay. Mnaona sasa? Okay. I was saying, now when you represent an alternating quantity sinusoidally ama graphically itakuwa kitu kama hii. Now let's say that this is voltage that is represented graphically as it varies with respect to time. The peak value ama the maximum value is the maximum value during a half cycle. And I was showing what a half cycle is. This is the half cycle. Hii hapa. If I was to show a full cycle, ndio hii hapa. Hii yote. A cycle is that place where the alternating quantity let's say a revolution, one complete revolution before it begins again. Mali the identical cycle itakuwa inaanza. So that is what we call a cycle. So the maximum value during a half cycle is what we call peak value. So it can be on the positive side or it can be on the negative side of that alternating quantity. Now these peak values are usually represented using capital letters. So kama ni voltage ni capital V. Kama ni current ni capital I. Sawa sawa. Now this peak value inaweza kuwa inaitwa amplitude. So ukiona mahali kwa swali umeambia tafuta find the peak value ama umeambia tafuta the amplitude, it means the same thing. Ama find the crest value. Crest is this part, the top part of that alternating quantity. Now peak to peak value. Peak to peak value. Now peak to peak value is the difference between the maximum and the minimum. Sawa. It is the difference between the maximum value and the minimum value in a cycle. Now this is our cycle over here. This is one complete cycle up to that point. So the maximum, let's say our maximum was 20 volts and our minimum was minus 20 volts. So our peak to peak value will be 20 minus 20, which becomes 20 plus 20. So it will be 40 volts. So when you take this value, the magnitude of that value, and then you add the magnitude of that value, it will give you the peak to peak voltage. Sawa? Are you together? Yeah. Is there a question up to that point? If you're together, please unmute and say that you're present. Naona leo watu wamenyamaza sana.
Yeah, we are present.
Okay. Now, there is something else known as average value or mean value. Now, when you draw your alternating quantity graphically, if I tell you to find me the average value of this alternating quantity, that is voltage, as it varies with respect to time. the average the mean value of this graph will be found by taking the area under this curve, the area under that curve divided by this length of that half cycle. In this case, we are talking about the area measured under the curve over a half cycle over that length of that half cycle. Sawa sawa. Mfano umepata that the area under this is, let's say, 50 or 500, and the length, remember now we're talking about length, but it is in time, ama whatever value itakuwa hapa. So let's say this is 20 seconds, so it will be 500 divided by 20 to get the average ama the mean value. Now this sana is usually this formula of area under the curve all over the length of that base, length of base. Tunatumia hii sana when you're dealing with curves that are not of this nature, non-sinusoidal curves. This is a sinusoidal curve. Ukipatiwa an alternating quantity that is varying, iko namna hii. You might find that whatever your alternating quantity is not varying at the same at the same rate. Labda kuna shida katika hiyo alternating quantity. So unapata kwamba hiyo quantity iko na mabonde na milima. Now we can still find the mean value ama the average value of this curve. What you do is you find the area under this graph, under this curve, over that half cycle up to that point of that graph. You divide it by the length of that base. Now how do we find the area of this such kind of a shape? Because sababu it's not straightforward kama ile area of a circle pi r squared ama area of a rectangle length times width. No. Now kuna vitu ambazo we are not going to be doing them because we are not doing mathematics. We have some ways of finding the area of such shapes. Kuna rule ambayo inaitwa mid-ordinate rule. What we do is we divide our shape. Kama hii hapa. Let's say this is our shape. I'm just talking about it briefly. Let's say that is our shape ambayo inakaa namna hiyo. And this is our half cycle. So what we do is we take this half cycle and then we divide it into equal intervals, equal intervals. Let's say this length yetu ni 5.3 centimeter ama 5.3 seconds. Unaangalia how many equal intervals can fit in 5.3. The size of the interval is up to you. Hakuna limitation. So you can take your interval to be, let's say, 1 centimeter. It can be 2 centimeters. But the more intervals you have under this shape, the better. The more accurate your calculation will be. So let's say I divide my intervals in Kapata that I have 3 equal intervals. So I will take the value of the instantaneous value of that quantity. Let's say this is voltage. I will take the value of that voltage at that point, at the center of that interval. At the center of that interval, nitachukua the value. At the center of that interval, nitachukua a value. At the center of that interval, nitachukua a value. Sawa. Now, once I know the instantaneous values, let's say this is I1, I2, I3, I4. This is small letter I, I4. My area will be I is equals to the square root of I1 squared plus I2 squared plus I3 squared all over the number of intervals I have. That will give me the area of that curve, whatever the shape, but we're not going to be talking about that now since you're not dealing with mahesabu. I was just showing you the formula of finding that area of that curve. Now, for a sinusoidal wave ambayo ina shape yake ni hii. For a sinusoidal wave ambayo its shape is defined, inakaa namna hiyo. The average tutarevise.
Is there any chance ambayo tunaweza tukarevise?
Tutazirevise, tutazipitia zote. Ama maswali yote tutayapitia sana, lakini tutatafuta time kwa sababu siku yote naona niko busy kidogo. Labda jioni from 5 to 6 hivi, ama Saturday tunaweza amua 8 to 9 asubuhi.
Mwalimu afadhali hiyo Saturday ile Ramadhani kwa 5 to 6.
Ni shida. Anaelewa lakini. Acha tumalize haraka kwa sababu time imeenda na naona umekawia. Kwa sababu sasa nilikuwa na explain, ukiwa umepatiwa graph which is sinusoidal in shape, kisha uambie utafute the average ama the mean value. Sijui kama mnaweza ona screen yangu. Moyona. Okay. You've been given a sinusoidal graph. Amoni mali naandika? Mnaona sasa?
Mimi naona.
Ala. Okay. Haya, sasa umepatiwa graph kama hiyo. Ukaambiwa utafute the average value. Kumbuka kwa ile hapo mbele nilikuwa nasema ukiwa umepatiwa a graph that is not sinusoidal in nature, labda graph ambayo umechorewa shape yake ni mbovu. Sijui nimechukua karatasi yangu wapi. Shape yake ni mbovu. What you do is you take the area under this curve and then you divide it by the length of that base. This is done during the half cycle. Now finding the area of a curve, nikaambia kuna njia nyingi za kutafuta hiyo. The most common one inaitwa mid-ordinate rule. Nikawapatia brief explanation ya hiyo mid-ordinate rule, lakini kwa sababu hatufanyi mambo ya hesabu nimeachana nayo. Sana utakuwa umechorea hizo intervals. Na what you do is, kama hii graph yetu iko namna hiyo na intervals zetu mfano ni hapa ni 3. Utachukua the value at the center of that interval. Unasoma. Unachukua the value at that center of hii interval. Unaisoma. So the area of that curve, tuseme our alternating quantity ni current. So the area will be the square root. This value labda ni I1 squared plus hii value hapa ni I2 squared plus the number of current ambazo utaweza kupata in those intervals. Labda you have 10 intervals, so you'll have 10 values of current. If you have 20, the better. Divided by the total number of intervals, n. So hiyo ndio itakupatia the area under that curve. But if in this case we have been given a sinusoidal shape, the value of the average value will be given by, so the average value or the mean value will be given by 0.637 times the maximum value. If your shape, your graph is sinusoidal, then the average value will be given by 0.637 times the maximum value. Maximum value tulisema ni hii value hapa. The maximum value. Hii 0.637 ni constant, haibadiliki. Ni kitu ishakuwa calculated. Sawa sawa. So this is for a sinusoidal waveform. If it is not sinusoidal in shape, labda waveform yako ni ile shape mbovu, Hiyo shape sio defined vizuri. Itabidi sasa utafute the area of this curve using different ways. Now, this is the average value. Another term, another AC value ni effective value, or root mean square value, inaitwa RMS value. Root mean square value. Now, this RMS value, root mean square value, it is assumed that the value ambayo unapata in your house, in your socket, is the RMS value. This is the, ukiwaambia or explain what RMS value is, the effective value, it is the current that will produce the same heating effect as an equivalent DC current. If let's say my current, let's say I have a DC current, a direct current of 240 amperes. The RMS value ni ile value ambayo it will give me the same heating effect kama hii DC value ya 240. That is just a simple explanation. So one assume that if you're given a value, if you're given a value katika mfano in your house, unaambiwa that the value ambayo inakuwa supplied, the voltage being supplied, the AC voltage being supplied to your building ni 240 volts. Huwa inakuwa assume that 240, unless stated otherwise, it is the RMS value. Kwa sababu ukifanya hesabu zako kama ukiangalia katika vitabu, haitakuwa imeandikwa 240 RMS. No, itakuwa tu imeandikwa 240 volts. So that 240 volts is assumed that hiyo ndio the RMS value. And it is usually measured, itakuwa represented using capital letters. So kama ni current ni capital I, kama ni voltage ni capital V. Now, for a sinusoidal waveform, ile ambayo shape yake ni defined namna hiyo, the RMS value is 0.707 times the maximum value. Na tukasema that the maximum value ni ile value ambayo ni maximum. In this graph, this sinusoidal graph, the maximum value is the amplitude, the peak value. So the RMS value will be equal to 0.707 times the maximum value. Now, we had introduced some other terms kama form factor na peak factor.
Excuse me, your arc is not clear.
Inapotea. For form factor, hii form factor na peak factor are factors ambazo zinakusaidia kujua the shape of your waveform. Your alternating quantity ukichora in a graph manner, form factor na peak factor will help you determine how that shape will look like. Now, form factor is given by the RMS value divided by the average value. So kama umefanya calculations zako ukapata RMS, ukafanya calculation ukapata average value, then it is possible to find the form factor. Na tumeambia hapa for a sine wave, hiyo wave ambayo inakaa hivyo is 1.11. Peak factor is given by the maximum value divided by the RMS value. Sawa. If you have the maximum value and you have the RMS value, then it is possible to find the peak value. Unachukua maximum value, kisha una divide by the root mean square, the effective value. And for a sine wave, that peak factor is 1.41. Now, there is some questions that ziko hapo, na nilisema hizi questions hatutazipitia saa hii, tutazipitia mwisho.